Hello everyone, welcome back to the channel. In part 1 of our SQL injection lab, we demonstrated how attackers could exploit a vulnerable login form to bypass authentication. But today it's all about defense. And as I promised, we will cover two common ways to protect your application. The first one is input validation and the second one is parameterized queries. We will also walk through working demos of both and explain how each one blocks an attacker. Before I get into explaining those two common ways that we talked about, I will first show you that I haven't changed anything from the previous video. So this is the init SQL. As you can see here, we just have created the users table, inserted some users, created a database and everything. It was the same. This is the Docker Compose that has two services, the database and the backend, and this is also the same. Then we have the server, which it's basically in the backend, right? It's part of the backend together with the database. And this here is where the vulnerability in our entire system is located, in this line here. I can show you the front end as well. We haven't changed anything here. This is just the form, username, password, and yeah, everything is the same. Now, this is just to show you that it's vulnerable. So, it's here, okay. So I don't even need to enter a password because I will gain access with just this injection. So as you can see here, I managed to authenticate as root. However, some of you might ask, well, why don't you make the once equal, right? So why don't you close it? Why do you leave it open? Well, that's just how I have written my code, right? So if I enter submit, your guys are gonna see this. Now, this is a good indication that the system that you're testing this on is vulnerable to MySQL injections. So it's not a bad thing, but you will just need to like trial and error until you find the right syntax that will allow you to authenticate as the user that you're looking for to authenticate. However, we can still manage to authenticate by just adding this comment here, which comments everything else. And as you can see here, we authenticated as root. Now I'm gonna get into the first way to defend ourselves against this type of attack, which is the input validation. I'm gonna use this graph to explain the logic behind the input validation part. Don't worry about this because this is coming, but for now I'm going to explain the input validation. So, the attacker enters the username and password. This is the first step where we will have our demo set up and ready for us to enter the SQL injection. Then, after we press the submit button, it will go to the backend and the backend will check if the format is safe. If the format is safe, then we will return the user. If it's not, then in our case, the way that I have set up my system, it will stop immediately. It will tell him that uh, it will prompt an output, which you will see right now, as I will write the new code while showing you, and then I will restart the Docker containers so the new changes will be displayed into the demo when we try to insert the SQL injection. So let's start with the first layer of defense, which was input validation. This method checks if the data that the user enters meets a certain criteria before it ever reaches the database. And we will do this by creating two variables first of all. And here we created the two variables. Now, you might ask, what is this? This is called regex. So, this line, the first line here, this line checks if the username is only made up of letters, lowercase or uppercase, and digits, and has at least one character, which this plus sign here is to check that. So I will break down this entire regex thing. So this indicates the start of the string, and this indicates the end of the string. Now, this checks, or sorry, this checks if the what the user has entered is only lowercase letters, right? So our input can have only lowercase, uppercase, letters from A to Z, and only numbers from 0 to 9. Nothing else is accepted. And that's the purpose of this test function. It checks if the username that is entered fulfills this criteria here. So let's say some examples that are correct could be, let's say, if the user enters Alice123, this is correct because we have an uppercase which is accepted, then we have lower cases which is accepted, and then we have numbers which are from 0 to 9 which are also accepted. Now, something that can be rejected, let's say the user enters Alice. The reason it will be rejected is because of this. We don't accept that in checking it as a constraint, right? These are the only things that we accept. So this will not work. This will print out an error. And as for this line here, now you might ask, if we did 0 to 9 here to check whether we enter only numbers, right? What is this slash, the backward slash? So this is basically saying 0 to 9, but it's just an easier way, right? So we can represent the 0 to 9 like this, with a backward slash and D. Now we will write the condition that does the checking. So, sorry. Now, if here we created the condition, it checks if the user, so basically if this is false, right? If the user is not valid, or if the password is not valid, this will be returned. And although we are keeping this query statement the same, which is basically vulnerable, it will not work as we have these conditions here, or this input validation defense. However, keep in mind, we will need to fix this because it's still vulnerable, and in case the attacker finds a way, they can still exploit this. So I will now run the Docker desktop. I will run the containers there, and then I will show you how this prevents SQL injection. Okay, so here we are. Now let's try this SQL injection here that we had. So let's try and submit this. As you can see, we get the invalid input. Only alphanumeric usernames and numeric passwords are allowed. Now we can try adding this here. Nothing changes. We can try commenting. Nothing changes. However, what if we just leave this as root and then submit? So we have user not found. It's correct because for the username, we had the three conditions, the three criteria, or sorry, the two criteria, no, three. So only lowercase and uppercase letters and numbers. So even if I have a root one, it's allowed. But if I enter something like a symbol, I will get invalid input because we don't accept it. And as for the number, sorry, the password, we accepted only numbers. If I were to enter A, it's going to give this. This makes it difficult for an attacker to enter SQL code like the root slash this here, because it fails the validation check and never ever reaches the query. But the thing is that this only protects you if the input is strictly controlled. If there is a bug in your validation, or if the validation is bypassed on the client side, you're still vulnerable with that query statement. And that's why we will now go into the second defense, which is the parameterized query, which will cover us in this aspect that we lack. Parameterized queries, also known as prepared statements, these are the gold standard. So this approach doesn't just check input, it separates it from the SQL logic entirely. So even if the user enters SQL code, it's treated as data, not executable commands. So as you can see here, we are on the form. The attacker enters the username and password. The backend uses placeholders for the SQL query, and then the database itself handles user input as safe, literal data. So I will now start writing the code and I will explain to you how this parameterized queries works. Now, when it comes down to parameterized uh, queries or statements, uh, there are just some small changes that we will need to do. But first of all, I will comment out this code that allows us to do the input validation. And let me just copy this really quick and I will comment this out. Now, this is just our normal code, right? This is the vulnerable website or version of our website. Now, in order to do parameterized queries, we need to do the following. So, wherever we put the user input, right, we will replace them with question marks or whatever, but I'm choosing to replace them with question marks. And over here, we're gonna do the following. And we're done. This is basically the parameterized queries version. The question marks are placeholders, and when you pass the username and the password, the MySQL driver handles escaping and sanitizing the inputs for you. So it does that for you. You don't need to worry about it. So if a user were to enter the root or 1 equal to 1, it doesn't get inserted directly into the query. Instead, MySQL does this. It prepares the structure of the query, which is this here. This is the structure of the query. And then it safely binds the actual values. If the username is root or 1 equal to 1, it will bind that entire thing as a string, not code, and the password, whatever it is, right? And the result is it will look for a username that is literally root or 1 equal to 1 and won't return anything unless the exact user exists. So the SQL injection attempt fails. Now we will try if the parameterized queries work. So we will try first with this root or root. So we have user not found because this user does not exist. We can try fixing it like this and we will get the same user not found. We can add a comment at the end and we will also get user not found. Now let's enter the right password and let's see if this works. Yep, it recognizes. And yeah, this is basically parameterized queries. This is how it works. It will take this SQL command here as a literal, as a string, right? Not as a command, as a code. And it will look for a user named this, but it does not exist. Now, there is a version where we can combine both parameterized queries and the input validation thing. And I guess that's the best approach you can take when designing a security habits in regard to user input, like to forms, if to protect your websites. And I will prepare the code and I will show you guys. And here we have the combination of the input validation and also parameterized queries. So we left this as it was. We have the question marks here that act as placeholders, and we have the input validation. Now, keep in mind, this input validation thing, you can consider it as a first layer of defense. And by combining it with parameterized queries, you have, I'm not going to say 100% secured your website, but it's a good approach when coding and keeping security principles in mind. And yeah, this is all from me for this video. Thank you so much for watching my videos. I really appreciate you guys. Uh, and as for the next video, I'm thinking about demonstrating how I set up this entire environment to test for SQL injection. It's not hard. However, there are like things like Docker Compose, Docker in itself, JavaScript, and databases, connecting them together and everything. Uh, I think it's good to like write the code and explain as I go. It's good for me as well and for you guys because I make these videos to keep myself pushing to look for things and learn more things, and I guess share it with you guys. Anyways, I thank you guys. I really appreciate it. Have a nice day.